Hello, hello. Today I have magnifying glass doublers by, I don't know if it's Lizzie 01 or just Lizzie 1. I'm going to say Lizzie 1 because I think I like the way that sounds. But apparently this is a sequel to magnifying glass that I have not seen. So if this puzzle's great, and if you're seeing this, it probably is, then let's go back and try that. And it has very few rules. Normal sudoku rules apply, which means that the digits 1 to 9 appear once each in every row, every column, and every marked 3 by 3 box. A list of thermometers, so digits strictly increase from the ball bend. So if this is, say, 2, this has to be more than 2. So it could be 4. This could be, say, 7, 8, 9. That would be fine in this puzzle. And then additionally, there are 9 doubler cells. So again, in every row, every column, and 3 by 3 box, there's going to be one cell that for the purposes of thermometers counts as double its actual value. So for example, if this were a doubler, which I'm going to mark doublers in red, well, maybe not. We'll think about that in a second. But if it were a 4, then for the purposes of the thermometer, this would actually count as 8. So I could have something like 7 doubled 4, 9. If these were, well, they wouldn't be doubled, but that would be fine. And additionally, each digit is doubled exactly once. So yeah, that's it. Let's go ahead and try and see what we can do. And if you can hear that, there's an air show in Chicago coming up soon. The rehearsals are essentially directly above my house, so that's fun. So clearly these big long thermometers have to be the break-in because they are 9 cells long. And if there were no doublers, what that would mean is that we need the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. I stopped on 5 because on this one we have the exact same thing. 1, 2, 3, 4, 5. And we have 5 in the same column, same row, I mean. 6, 7, 8, 9. So that means at least one of these has a doubler in it. And what does that mean? The doubler... I'm trying to think exactly what that means. It's actually not that obvious because at first I thought the doubler means it's going to be the highest cell. No, that is true. The doubler, one of these is a doubler because if not, then this is at most 9 and we get the values if not the digits 9, 8, 7, 6, 5, 4, 3, 2, 1. In that case, I do end up with the value 5 here, which would only come with the digit 5 because you can't double 2.5 to get there. So one of these is, if not both, is a doubler. So these are not doublers, which should not be surprising. And since they're not doublers, and I can't have 2 doublers in a single box, at least one of these is 9. So these non-doubled cells are either 1 or 2. Seems like very little. What that actually, the thing I'm realizing now is one of these is a 6. Because I want to pencil mark these because these are values and not digits, but the values on everything up to the second spot is 1 or 2, 2 or 3, 3 or 4, 4 or 5, 5 or 6, 6 or 7, 7 or 8, 8 or 9. Because this value cannot possibly be higher than 9. Because if it's higher than 9, it means it's a doubler. And this will not be a doubler, it can only be 9. So this could be 9 if this is doubled. But only if this is doubled. And if this isn't doubled, then this is less than 9. So it's either 8 or 9. So it means these in value are 5 or 6. Now they could both be, one could be a real 6 and one could be a doubled 3. But at least one of these is 6. So at least one of these is 7. No. One of these is 7. One of these is 8. One of these is a 9. A real 9. And one of these is doubled. At least. All of those are at least. What does that mean for this? In value, I mean, basically the way I'm going to think about thermometers is they can go up to 10 essentially. The high number can be more than 10, but there are 10 kind of places essentially. That's just the way I think about placing digits, is kind of on a spatial line, and you just move them around on a thermometer. And the high digit might be like 14 if it's a doubled 7, but there's really only 10 slots. So there's the value 1, value 2, value 3, value 4, value 5, value 6, value 7, value 8, value 9, and then something doubled higher than 9 are the 10 possible things. So this is either 7, 8, 9 or a doubler. Okay, I'm sorry, I'm having trouble figuring out how to exactly use this. This is 1, 2, 3, or 4 value, which seems like it. I mean, there's really not that much conflict here. I mean, I get a little bit of conflict in that, like, these both see this. I don't. It just seems so. It seems surprisingly loose, given that there's really only 1 degree of freedom on these thermometers. The problem is I can't mark them with doublers. Hold on. So this is 2 or 3, the digit, I think, because this couldn't be a doubled 1, because then what would I put here? So this is the value 2 or value 3, and the value 2 would have to be the digit 2, and the value 3 clearly has to be the digit 3. So that's right. So that's not a doubler. Let's start there. I'm going to change the greens. I'm going to change the greens to yellow and make the doublers blue. I don't know why. I'm just not going to use red and green for colorblind reasons. So I don't know why yellow is one and blue is the other, but I think that'll work. So this is value 3 or value 4. But this could be a 2. This could be a double 2 because I could have 1, 3, doubled 2, 5, 6, 7, 8. Oh, no, that doesn't work because I see. Okay. So this is also not a doubler, because if this were a doubler, maybe try to do this for each one. If this were a doubler, then this would not be, meaning it's a 9. 9, 8, 7, 6, 5, 4, 3. And 3 can't be on the doubler. So this is true. Let's try that here. This is 5. Could this be a 3 doubled? No, because if this is a 3 doubled, that's a 4. Oh, no, that's right. 4, 5, 6. That's what it should be. So this could be a 3 doubled. Okay. I want this one. 3, 4, 5, 6, 7, or 8. If this is a 4 doubled, then that's a 3. Which is fine. It could be low, and we could have a gap somewhere in here. No. Sorry, this can't be 4 doubled, because if this is 4 doubled, it's an 8. This would have to be doubled. So this actually is not a doubler, and this is 7 or 8. The reason it's not a doubler is if it were a doubler, this would have to be, this could not be a doubler. This would be at most 9. It would be exactly 9, actually. And we have 9, 8, 7. We can't double the 7. This could be a doubled 4, right? Doubled 4, 9, 7, 6, 5. Oh, 4, 3, 2. No, wow, that's not a doubler either. And all of these, everything I'm doing here is just based on the shape of this, so that they're going to apply over here as well. Which means there's a doubler on this thermo. Right, because this is 2 or 3. This is 8 or 9. This is 8 or 9. This is 9 or a doubler. I mean, I could do something like this. It seems so inelegant. The marking. I'm sure there's a nicer way to see this. I mean, I don't see anything yet. I'm trying to figure out what the actual logic is here. Could this be a 2 doubled? I think so. 2 doubled have to have 5, 6, 7, 8. Yeah, that doesn't prevent anything. Oh, no. 2 doubled here. Hold on. This is value 4, value 5. If it's value 4, it'd be 2 doubled, but that would mean this would be value 3, which doesn't work. So this is not a doubler. I mean, I'm sure. Does that hurt? 4, 5, 5, 6, 6, 7. Could this be a doubled 3? Yes. Doubled 3, 5, 4, 3, 2, 1 seems okay. Can I do something with this now? There's no way. Is there any way this is a doubler? Could this be a doubled 1, for example? Then we have 3, 4, 5, 6, 7, 8 at least. And this would be 2. That actually seems okay. Well, actually, if this is a doubler, this is not. So we get 9, 8, 7 here. So we would get doubled 1, which is really a 2. Oh, no. If this, yeah, this can't be a doubler. Because if this is a double, if it's a doubler, it has to be 1. Because we have 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9, 10 needs another doubler. So if this is a doubler, it's a 1 doubled to 2. But that means this is not a doubler, which means that's 9. But that means this is 1. So that doesn't work. So that's not the doubler. Which means it's 1. Because this is a 1. Yeah, this is the break-in. This is a 1 because if it's a 2, I still need a 1 in the row somewhere. And if I double the 1, that's 2 again. It's not going to be bigger than 2. So this is a 1. And here I get 2, 3, 4, 5. This could be a doubled 3, I think. No. This is a doubler. Let's start there. This is a doubler. So this is 6. Now this is, hold on, 8, 9. This is at least 5. And now this is value 7, so it's not a doubler either. Cool. I like that, actually. It's a lot simpler than I was trying to make it out to be. I don't know why that was hard for me to find. And then I get a 3 in here. I probably just shift focus to here now because I've got all the digits essentially. Or maybe it's here actually. The only digit I'm missing. Does this have to be the doubler? Hold on. Because if something doubles, it's going to be something else on the line, I think. Because if this is... So the digit missing here is either 2 or 3. Let's suppose the missing digit is 2. And these digits are 3, 4, 5, 6, 7, 8. Right? And first of all, 8's one of those, because it's either doubled, in which case it's at the end, or it's not doubled, in which case it could be at the end, or it could be here. But there's no way it's in here. Because I can't get 2 digits higher than 8, because 9's taken. So, suppose 2 is the thing missing from this line, besides 9. Then we have 1, 3, 4, 5, 6, 7, 8. What can I double that would not either replicate another digit or be higher than 8? If I double 3, that's 6, which is already there. That's a no-go. If I double 4, that'll be 8. Again, duplicated, no-go. 5, it's bigger. Now, if 3 is missing, same problem. 2 doubled is 4, 4 doubled is 8, 5 doubles at the end. So this is the doubler, whatever it is, which is blue, which could be 8, actually. But importantly, none of these are doublers. So this is 9, 8, 7. This is 3 or 6. This could still be a doubler. 5, 2 or 4, 3, 2, 1. Now 2 is what's doubled, meaning there's a 3 in here. 3 doubled is not bigger than 8, so 3 goes here. 4 doubled is not bigger than 8, so that goes here. And what we're left with is 5 or 6. It's 6 if 5 is doubled. This can't be 5 anymore, so it's 6 or 7. This is... Hold on. 5 is doubled. This is 6. This is 7. If 6 is doubled, this is 5. This is 7. If 7 is doubled, 5, 6. Yep. Anything higher, 5, 6. So this, could this be 6? If this is 6, no, that won't work here. So this is 7 or 8. And this is anything, but not 5 or 7. So this is 6 or 8 actually, which means this is 5. Okay. Now what do I do? One of these is a doubler. It's probably this. What am I missing in this? I need a 9. Here we go. I need a 9 in here. Oh, it could go here. That's not it. It probably is there, actually. All right, what am I missing here? Oh, the evens. 2, 4, 6. Okay. Okay, let's think about this again. Oh, this can't be 1. So 1 is on the thermo. And for the exact same reason as here, this is an undoubled 1. Because, oh no, it doesn't have to be an undoubled 1. It has to be 1, but it doesn't have to be undoubled because this could be a doubled 1 and 2 could be here. And then I could have, 4, 5, 6, 7, 9, something like that. But that does give me 1 here as well. Oh, but look at this. If this is a doubled 1, this is also a doubled 1 because the doubler in this column would have to go here. So this is not a doubled 1. Look at that. And now 2 is in one of these places. Oh, no, if it's double, that's still a problem because the 3 is... I was thinking of 3 double 2 or something, but that doesn't work because the 3 is already taken. And I can't have double 2, 4 next to each other on the same... It can't be on the same thermo at all because they're neither is strictly above the other. So what? This can be the doubler, right? Because if this is the doubler, either of these could be a doubler. Okay. So there's this non-symmetry here. Oh, 1 is one of these. So 1 is one of these. 9 is not. Oh, 9 could be here if I have a big doubler here. Oh, this can't be 2. That's a 4. Simple Sudoku, as usual, to the rescue. 4, 4, 4. Yeah, maybe I should just do a little Sudoku. Although it's not obvious where that would help. 9 here, 7 here. I guess these 3 digits are... These 4 digits are 3... Oh, 5 and 7. Look at that. It is Sudoku, kind of. Well, no, that's Sudoku. This is 3, 9. These digits are 4, 8, and 2. So 8 is one of these. Is there any problem with this being a 5? I don't think. I mean, this is such a short thermometer. Okay, what about, let's go back to this. Now that the missing digits are either 2, 4, 6, or 5 or 7. So there is a 9 here. Not 9 is now, yeah, 9 is now here. Yeah, that was what I needed. That is a 9. Can't be doubled because I think it's bigger than it. So the reason for that is, suppose I try to put a 9 here. Now I need 2 double digits higher than 9, which will be in the same row. It doesn't work. Same problem here. If this can't be 9 because so this has to be 9. It has to be undoubled. Whoops. Has to be undoubled because if it were doubled, nothing could possibly be higher than it. So here I have a doubler, which is at least 5 as well, and not 8 or 9. And now I need it. No, this could be the 2. These are undoubled. So I mean, I can kind of place these digits. This is 2 or 4, I think. Because if this isn't 2, this is. And if this is 2, this is 4. Oh, but it can't be 4. So that's 2. It can be 4 because of this. And this is just whatever is not encompassed by these 3 digits. Which is not 5, actually. Oh, hold on. There's something going on with this. There is, because one, look, where is 5 in this row? It's either here, in which case that's 7, or it's here, in which case that's a doubled 5, and that's a 7, because they can't be the same digit doubled. So that's really nice. That is so cool, Lizzie. Well done. This is a 7, which makes this a 5. And now 7 here makes this a 6. I love that. And just keeps going back and forth like that. That's so cool. These are now not 4. And then I get a 2 here. Specifically, I need a 3 and a 5. I still don't know those somehow. I wish I could put this 3 double. That would do so much. But this could be just a random double. Oh, this is now an 8 at least. So 6, 7, and 8 are now doubled. I need a 9 doubled somewhere. And it's not here. Could be here. I could be here. Okay, let's do... This can't be 1. So one of these is a 1. No restriction on a 3. 2 is one of these. 8. Oh, look at that. That is a double 3. There we go. I get it from the other way. I thought I was really hoping this would be double 3 because it does so much, but I was thinking, how do I show that's not a doubler? But what I actually had to show is that this wasn't a 6. Yeah, kind of when I'm thinking about what to look for next, I'm often thinking, you know, what would really help if I found it in the puzzle? And then I think, what's the most likely way to show that? Which maybe is a little bit of a backwards way of thinking about it, but it tends to work for me okay. I'm missing here 6 and 9. That's being a 9. No, not 6 and 9. 8 and 9. That's less helpful. Oh, but it's actually quite helpful for this, because there's no way this can be an 8. It definitely can't be a 9, because I have 2 digits higher than 9. Oh no, they could both be doublers. I'm full of it. I'm absolutely... And I bet that's... Well, hold on. Yeah, this could be 5 doubled and 9 doubled. Wow. It just... I mean, I bet that's what it would be. This is going to be 9, 5 double. I mean, it's too beautiful not to be true. Hopefully you don't feel bad if that's not the way it goes. 4, 5. 6, 7, 9. 7, 9 by this row. I have to go here, and I know the order. 7 can't be doubled again. 9 could. These are now a 6, 8 pair, whose order I don't know. But I know they're not doubled, which means this 9 is my double. Ah, okay. So apologies. My prediction about this is incorrect, because now I get to use the inverse of that very nice logic, which is that this can no longer be a 9. Because if it were a 9, I would need 2 doublers here that were ended up higher than 9, which means they have to be from 5 plus. But 4 of those are already taken, so I only could possibly put a 5 doubler here. The other one would have to be 9 or less. So this can't be 9. It doesn't get rid of... Oh, it does get rid of 8 as well, because it's a little hard to see, but this is 8. Because of this 9 here, this can't be 9. So this would also have to be a doubler of at least 5, as with this. So this is now my 1. This can't be 1. So again, X-wing on 1's here. This can't be 1. So I get a 1 here, which fixes these. And the 1 can't be a doubler because I already have a doubled 1. These, what do I need here? I need a 4. Not so exciting. Here I need a 3. 3, 2, 1 still works. 3, 5, and then either 6 or 8. Oh, this can't be 5. Oops, not what I wanted to do. This is 3, 6, or 8. Yeah, 3, 2, 1 still works. What are these digits? These are 2, 4. So these are 5, 6. This just feels like it's not restricted at all. Oh, 3 is looking over here. Very obviously. 8, 9. That's not 8 anymore. I need a 3 here. I need another digit here. That's not 2, 4, or 6. It's a 7. Oh, interesting. Could this be 7? No, because this... If it's 6 or 8, it's not doubled. So this is at most 8. So this can't be 7. So that's 1 and 7 this way. 7 is here, undoubled, because it just is. Because I already have a doubled 7. 1s can't be doubled. So that's a doubler. These are now all undoubled. Yeah, this is 5 and whatever I'm missing from here. I should have 2 known digits here. Oh no, because I have 3 unknown. So I have 1. Only, yeah, it's the same thing. It's 3. I know there's a 3 here. Okay, what am I missing doublers? I have, oh, what is this? 2, 4, 5, 6, 9. 2 or 9. 9 is already taken. So that's a 2. Oh, that's really helpful. So this is either 2 or 3 undoubled. Not a 5. Not a 3 either, actually. 2, 8, 6, 9. I believe this 5 could be doubled. So the things I'm missing for doublers are 4, 5. So could in fact, where's my doubled 4? It's one of these. And not, in fact, it's right here. This is my doubled 4. This is, whoops. Well, I could leave it there. But here's my doubled 5. The rest are undoubled. I'll delete those. And now it's just thermo sudoku. 3, this is 6 or 8. Oh, this should be easy. What are these 3 digits? These are 3, 8, 9, which means this is 6. This is not 2. 4, 5, 6, 5, 2, 4, 2, 4. There we go. 6, 8 on the thermo. Makes this 6, 8, 6. This is a 3, 5 pair. Whoops. This should be a 2. This is 3, 4, 8. 8. 3, 4. Making this 9, 3, 8. Great. Oh yeah, I really like that. I love this opening. I enjoy this one anti-doubler logic. I enjoyed that I was very wrong about this. And still got to use an inverse of the beautiful logic I saw with the 8 9s going up. Yeah, just a really nice puzzle. I really like this. So thank you for posting that. And thank you for watching. And I will see you next time.